Hi, my name is Ray Chambers. I'm a computer science teacher, and I'm just going to try using this whiteboard here to try and break down Kmaps for you and some Boolean algebra. Now, Kmaps are used to spot patterns within circuitry, basically, and there's a number of rules that you need to remember. Now, beforehand, they might sound a bit confusing, but as we go through this lesson, things will get a lot easier. So the first thing we need to think about is that we can only use one digit at a time. We cannot use zeros. We must group rectangles or squares. There can't be any diagonal groups. You need to group as large as possible, group by ones, and group by 1, 2, 4, 8, and 16, and so on. You can overlap and you can wrap the patterns, and you always go for the smallest number of groups. Now, the first thing that you need to know is what the Boolean algebra symbols are. So what I'm going to do is I'm going to draw some logic gates, I'm going to rub them out, and I'm going to explain how you can start to simplify Boolean algebra. So if you remember, the first thing we've got is a simple, okay, so what I'm drawing here is an AND gate. Now, an AND gate the symbol for that is the Boolean algebra symbol for that is an arrow pointing up. And that's quite easy to remember because I like to think of it as an A. I imagine that there's another line underneath it and it helps me remember that. Now the next one you have is an OR gate. So we draw that. And the OR gate is basically the opposite. So we go like that. So you've got the OR gate there. Now we've also got our NOT gate. So we're going to draw our NOT gate. So that's our NOT gate. Remember, it's a triangle with the circle on the end, which inverts the signal. And the NOT gate looks like that. And then moving on from that, we also have our AND, OR, NOT, and exclusive OR. And your exclusive OR looks like a circle with a plus in the middle. So they are your basic Boolean algebra symbols. What I'm going to do is I'm going to continue this lesson. I'm going to rub this off the board and cut to going over our first simplification of Boolean algebra. Hope this has been helpful so far. What we've got here is a simple table, truth table, and we've got our values that have been given to us. So what we need to do is now put it into a Kmap. Now to do that, you put your A at the top and your B at the side, and then you put your outcomes. So I'm going to put an A there again, and an A there, a B there, and a B there. Just going to rub this out. So basically what we have is a 0 or 1, a 0 or 1. Now if you read your truth table, 0, 0 is 0. So I'm just going to go over here. 0 and 0 is 0. 0 in A and 1 in B is a 0. 1 in A and 0 in B, so 1 in A and 0 in B is a 1. 1 in A, 1 in B, so B is true, A is true, and that is a 1. Now what we have over here now is a group. So this is our group. Now, what you do is you spot what they have in common, okay? Now, with A, both of them are in common, but if we look at B, they're different. So B has no impact on the outcome of this Kmap. So this pattern here, therefore, is A. So that pattern is A. Now, I'm going to rub this Kmap out and this truth table, and I'm going to draw another Kmap, I'm going to make this slightly bigger. Okay, so this time I'm going to do A and B. I'm going to put my A across the top, B, B, 0, 1, 0, 1. Okay, so you should be able to see that quite clear now. So this time, what I've got is a 0 here. And you have to imagine that I've been given my truth table. Now, what you can spot here is you can spot two patterns. So there's a pattern here, and there's also a pattern here. So I've got one pattern here and one pattern here. Now, again, what we've got is A. The outcome of B does not affect what is in A. This is just 1. So therefore, this is A. Now, the same applies to B. B is 1, but if you look at A, they're different. So what we've got here is A or B. Now that, simplified, is A or B. So our next Boolean expression here is we've got our truth table, and if A is not true and B is not true, the outcome is true. If A is not true and B is true, the outcome is true. If A is not true, if A is true and B is not true, the outcome is true. And if A and B are both true, the outcome is false. So what we're going to do is we're going to put this into our Kmap. So you can see here, if A is false and B is false, the outcome is 1. So it's true. If A is false and B is true, so A false, B is true, there's a 1 there. A is true, B is false. A is true, B is false, the outcome is 1. And then that's if A is true and B is true, the outcome is false. Now what you should be able to spot there is that we have two patterns. We've got one pattern here and one pattern here. Now again, what you do is you spot what they have in common. So you can see here that these are both if A is not true. So if A is not true, these are true. So our first pattern, if you look at B, it doesn't have any impact because these are different, 0 and 1. We've got not A. So that is not. If you can't see that, that is the not symbol. Okay. Then we've also got here not B. So that truth table as a Kmap, as an expression, now becomes not, let's make that nice and big, not A or not B. Not A or not B. Now, the next clip, I'm going to start stepping it up a bit, and we're going to go to some more complicated Kmaps using 3 variables, because these have all used 2 at the moment. So watch the next clip and see how you get on. So this is a simple 3 variable Kmap. Now, what I want you to do is maybe pause this video and see if you can spot where the patterns are. So if you pause it at this point, see if you can spot the patterns, see if you've got it correct, and then play it afterwards. Now, the first thing that you need to do is spot the patterns. Now remember, if we look at the rules, over here we can group by 1, 2, 4, or 8, or 16, and so on. So in this case, I can see 2 groups. Now, you can't do this because remember, it says the smallest number of groups. So you can't do a 2, a 2, and a 2, because what you can actually do is make just 2 groups, and that would be 3 groups. So I'm going to get rid of those. So the groups that you should have spotted are the group of 4 here and the group of 4 here. remember that you can overlap. Now, what do these have in common? Well, if you look here, whatever A is in this column, no matter what happens over here, because even when these are different, this column is A, okay? No matter what happens here to the B or the C, this becomes an A. Now, if you look on this side, what do these have in common? Well, this is, in fact, I've left these out, so it might make this a bit more complicated for you. 0, 1, 1, 1, and 1, 0. So this column represents B, and this column represents C. Now, if you look, in this column, B are the same at all times. So therefore, that is B. So what that basically is, as a simplified expression, is A or B. Because what you've got here is they have B in common, C doesn't matter, and up here, A is true all the way down. And that's a free variable Kmap. We're going to step things up and do another. Okay, we've got a set of free Kmaps here, and the first one that we're going to look at is the top one. And what you can see here is there are all of the values from a truth table have already been put in there. But what we've got here is one group of 4 and another group of 4. Now, the top group of 4, you can see wherever C is not true, these are turned on. And then you can see that they don't have any in common up here. So this is not C. Now this group here, what do they have in common? Well, A is true in both, but then B is different, so B is redundant, so then you have A for this group. So what you end up with is not C or A. So that's for the top group. Now, what we have over here is a second Kmap. Notice in here where A is true and B is true, and there, if you look, the same in the rest. So this one is quite simple. A is true and B is true. So this Kmap here is simplified as A and B. That's quite simple. So that one is A and B, okay? Now this one here at the bottom has a wraparound technique that we talked about earlier that you haven't seen yet. Because what you can do is this bottom group here, imagine that wraps around, so we got the top group wrapping around with that. Now what do they have in common? A is different, so that's made redundant. B is different in both cases, so that's made redundant. But if you look here, C is not true in both cases. So what we've ended up there is a not C, and that's what that group is. So that's how you do wraparound techniques in the Kmap. I hope that's a little bit more helpful. Now, to finish this video, I'm going to give you 2 examples of expressions you'll be expected to put into Kmaps, and I'm going to break them down for you so that you can understand them more clearly. You might not be able to see this quite clear here because of the light on the board, but I'll put this in the description below. Now, what you've got is not A and not B and not C, or not A and B, or A and B and not C, or A and C. Now what I do with that is I generally, wherever there's a change in the symbol, that's where I group them. So what I've ended up with is not A and not B and not C. So I've grouped that with brackets. Then it's or not A and B, or A and B and not C, or A and C. Now, in a truth table, in a Kmap, this looks like 1, 1, 1, 1, 1, 1. And what you should end up with is 3 groups, because you can see here that is not A, not B, not C. So that's how I've got that one there. That one is not A and B. So not A and B is true in both of those cases. This one is A and B and not C, A and B and not C. So that one was turned on, and that one was A is true and C is true. So that's why that one was turned on. So I'm going to group those. So I end up with 3 groups there, basically. Now, the next thing that I need to do is look at what each of those groups have in common. So the middle group, the thing that it has in common is that it is B. This group over here has A in common and C in common, but they're all not. So what you've got is not A and not C, or B, or, and this group here has C and A in common. C is true here and A is true here. So that becomes C and A. So what we have here is a 4-variable Kmap. So we've got not A and B and C and D, or not A and B and C and not D, or A and B and C and D, or A and B and C and not D. Now what you do again is you're going to need to put that into brackets so that you can do it section at a time. So that's me separating this up. Now when we put that into a Kmap, what it should look like is so if you want to pause it and try it first, again put the question below so you can try it, is it should go into your Kmap like this. You should end up with one group, because not A, so we know that this is not A, so not A, B is true, C is true, and D is true. So that was the first one we put in. Not A, so it's not A, B is true, so again it's in this column, C is true, and not D, so that's how we got that one. A is true, B is true, C is true, and D is true, so A, B, C, D, so that's how we got that one. And then A is true, B is true, C is true, A, B, C, and not D. Now if you group that together, what you should end up with, what they have in common is B is true and C is true. So simplified as an expression, you should end up with C or B. So C or B C and B can be true in that case. I hope those clips have been useful. If you have any questions, just drop it in the comments below. Thank you.